हॅलो. हा हा बोला ना. ठीक आहे, एक मीटिंग मध्ये आहे, 5:15 वाजेपर्यंत येतो मग. ओके ओके, थँक्यू.
Hello. Hello.
Yes.
Yeah, am I audible to you?
Yes, sir.
Yeah. Okay, fine. ठीक है. Just we are waiting for 5 minutes and then we will start the webinar. Yeah. Okay.
फोन कर लेना।
अच्छा
Hi Santosh. I just wanted to know that can I share my screen? Hello, Santosh.
Yeah, hello.
Hey, hi Santosh. This is Vivek.
Yeah.
Do allow me to share the screen so that I can show the presentation.
Yeah. Just give me. We will start the
Okay,
webinar, and then I will share
sure.
the option to share your screen. So just
Okay.
start in 1 or 2 minutes. Yeah.
Okay.
I will just give a short welcome address, and then we will start. Sir. Yeah. Just 1
Sure.
minute.
Sure.
Okay. I guess my audio is audible to all the participants.
Yeah, I think we can.
Yeah. Oh, yeah, fine. So more participants are joining. So I guess we should start on time so that we go as per the schedule. So good afternoon, honorable speakers, industry colleagues, and ladies and gentlemen. This is indeed a great pleasure for me to be with you here today. On behalf of the organizer, that is Genesis Info Media, the publisher of Smart Energy Magazine, I extend a warm welcome and thank all the speakers, participants, delegate, and special invitees to this webinar on the topic of National Green Hydrogen Mission, opportunities and challenges of the sunrise sector. Today we have many participants, industrial experts and professionals. These are joining this webinar, and our participants are from different industries, including solar, renewable energy, electric and power, automobile, electric vehicle, charging infrastructure, battery and energy storage, hydrogen and hydrogen fuel cell, etc. I would also like to inform here that this webinar we are streaming on YouTube also. So in addition to the Zoom, people are also watching it live on the YouTube also. So we are all aware that I would just give a brief introduction before we actually go to the webinar of the actual topics of the webinar. So we are all aware that India is undertaking a resolute march towards a sustainable energy future. Prime Minister Sri Narendra Modi ji has pledged at COP's 26 towards a net zero India by 2070, and this promise is accelerating this momentum. Central to a decarbonized India is widespread adoption of renewable power and vehicle electrification. Targets and policies such as 500 gigawatts of non-fossil fuel electricity capacity by 2030, FAME 2 scheme for faster adoption and manufacture of electric vehicles, production link incentives for encouraging manufacturing of advanced cell chemistry batteries are few steps taken by the government towards fulfilling this promise. To further complement this ongoing effort, India is prioritizing green hydrogen as a potential solution to decarbonize hard to abate sectors such as refinery, ammonia, methanol, iron and steel, and heavy duty trucking. Addressing the nation on the 75th Independence Day, Prime Minister Narendra Modi ji announced the National Hydrogen Mission with an aim of making India a hub for the production and export of green hydrogen. The effort has resulted in recent approval of National Green Hydrogen Policy with an outlay of 19,744 crores. The mission will have wide-ranging benefits from creation of export opportunities for green hydrogen, decarbonization of industrial, mobility and energy sector, reduction in dependence on imported fossil fuels and feedstock, development of indigenous manufacturing capabilities, and a lot more. Today, we here all come together at the webinar to get deep insights into the National Green Hydrogen Policy, the upcoming opportunities, the challenges that need to be addressed to make India a hub for green hydrogen. And for this, we have stellar lineup of distinguished speakers to give deep insight into the technical, policy, and commercial aspects of green hydrogen. The aim of the webinar is also to encourage you all to participate in the National Hydrogen Energy Mission and to contribute in making India the next green hydrogen hub of the world. I am optimistic that all participants will acquire new skills and knowledge from this webinar. We encourage all the participants to take active part in the discussion. Our wish is that you will enjoy this webinar, contribute effectively towards it, and take back with you knowledge, experience, contacts, and happy memories. With this, I would like to once again extend a warm welcome to all the speakers, participants, and industry colleagues. So we will start the webinar with the first topic.
Santosh, can you allow me to?
Yeah. Just give me. I'm just introducing you. Yeah. So the first topic today is of green hydrogen market opportunities and application. And the speaker is Mr. Vivek Prasad. He is VP Business Development at Infinity Global. Before I hand over to him, a brief introduction about him. Mr. Vivek Prasad is a techno-commercial project management professional for 16 plus years of experience in the field of renewable energy, hydrogen, green hydrogen, ammonia, water treatment, oil and gas sector, BOO, BOT projects. He has experience in B2B technology sales, project execution, financing, modeling, project management. Additionally, he works on technology feasibility, project feasibility, market research, cost benefits analysis on the projects, project contracts on PPP, both government and private. He was also mentoring CBWF, a foundation advising small-scale women entrepreneurs in India and abroad. He is currently working as a Vice President, Business Development, Project Development Activities, Technology at Infinity Global for green hydrogen, ammonia, and water. A warm welcome to you, sir. And you can start your presentation. Just give me. I will share the.
Can you allow?
Yeah. Just.
Sure.
Yeah, you are able to get the. Yeah, okay, fine, thanks.
Yes, are you able to see the presentation?
Yes. Yes.
Okay, so I'll just start the presentation. So just one slide about our company. So we are basically renewable energy developers who actually are into several countries in India, US, Europe, and Japan. We have about 4.5 gigawatt of portfolio, and we are actually into providing solutions for net zero carbon sustainable economy. And as of now, we have an investment capacity of more than $1 billion for different projects, primarily into renewable energy, green hydrogen, green ammonia, and circular economy. So these are the things just to mention. But let us discuss the main topic here. So before going into the market and market opportunities and what are there, first let me give very basic idea about what actually is we're talking about here in terms of green hydrogen and ammonia system. So this is just a basic flow diagram which actually mentions that how a simple hydrogen system is, or a simple hydrogen plant and as well as ammonia plant will look like. On the left hand side, you will see that there is a hydrogen generator, which is actually basically is electrolyzer. It is powered by a power supply, renewable energy, and from the other side you get water that actually ultimately you need purification. If you're using alkaline technology, then you have to use purification and then hydrogen storage, and further into ammonia generation if you are planning for ammonia generation. So this is just a basic flow diagram which gives you an idea about that. This is a flow. Again, this is a very basic layout of an alkaline-based technology. On the middle, you will say that C is a core of the electrolyzer. That is electrolyzer. On the right-hand side, you will see that it's a renewable energy, and obviously you have to convert the AC power into DC and then power these electrolyzer. There is hydrogen separators, oxygen and hydrogen separators are there. So basically this comes into balance of plants. You obviously need cooling water to reduce the temperature so that it can be utilized again, right? So this is just a flow diagram of a alkaline based electrolyzer. I think for PEM based and the SOEC, you will get more information as and when we move in the webinar. So again, so if you are going for ammonia, green ammonia, when you say hydrogen, green hydrogen, then you talk about green ammonia. So when you're talking green ammonia, basically you're saying that you're using green hydrogen and air separation unit, which actually will generate nitrogen, and that nitrogen put into a high pressure and high temperature reactor with iron catalyst will give you ammonia. So that ammonia obviously is in the gaseous form and it has to be cooled so that it turns into liquid, right? So this is just a basic process again of ammonia. However, complication is there when you talk about detailed level of engineering in these process. So I just wanted to give an idea that how this production of ammonia and green hydrogen will look like. Let us go further into the how a structure usually, because we are a developer, so I'm just giving you an idea about how a structure and business model for hydrogen will look like. So if you see, this is one of the models which we are trying to see and work out. This is very similar to the renewable energy. What we do is like similar to the RESCO model. Only basic difference is that there was the pricing of hydrogen or ammonia is based on per kg or per ton of the output. In case of renewable energy, it was per kilowatt of power. So at the end of the day, one is the end user of this green hydrogen. In between, there is a developer of green hydrogen project as well as the ammonia project. And obviously, the developer has to take a technology risk and the renewable energy cost risk. So that is how the structure will look like for a much bigger projects, because the developer will be doing such projects and then will have an offtake agreement with the clients. On the right hand side, you can see that what things are usually included in a pricing when you talk to the client about such projects. Moving to the factors that decide the market for green hydrogen and ammonia. So let us first understand that how the pricing of hydrogen is getting affected by different factors. One is the cost of power. Now, cost of power is depending upon 3 to 4 important things. One is definitely the banking for green hydrogen projects. When you are setting up you want a green hydrogen. So you know that there is an intermittent supply of renewable energy. Renewable energy cannot be a 24/7 work. So therefore, you have to make sure, or you have to try to get a banking facility for the green hydrogen in that particular state. So banking in the green hydrogen projects is very important. Otherwise, if the banking is not available, the cost of power will increase manifold. The reason behind that is that to set up a X size of hydrogen plant to get that 24/7 output, you have to set up a much more bigger size of the hydrogen plant in that case, and the renewable energy, right? So therefore, that is one of the factors. Then TOD is the important factor. Time of the day is defined in different states depending upon the peak and the peak demand and the non-peak demand. So that has to be considered. Then third is the contracted demand charges, because green hydrogen company itself is the consumer, right? So if they have to get a connection and locally from the government and take the power from the grid, then definitely they have to pay a contract demand charges of the size what they are looking for, right? So that actually affects the end, you can say, end price of the power, right? Then obviously, if you are getting a power from another state, even though the government has allowed no transmission charges, they have given some waivers on these things. You have to see that the CTU is near to your plant location. That also will affect the whole cost of power. And then finally, the power curve. The power curve just shows that what sizing of high wind and solar has to be put up so that you get the maximized level of CUF for your hydrogen plant. Now, the second most important factor, which affects the pricing of hydrogen, is the water availability. Now, water availability is required for the electrolyzer and for the cooling purpose. Okay. Now, as see the cost of water in terms of as a percentage in terms of the cost of hydrogen in the market is very low. So the price doesn't affect that much to the cost of hydrogen. However, the availability should definitely be there on a 24/7 basis, because if the water is not there, then definitely there is no hydrogen production itself, right? So if you are planning for ideally, I'm just saying ideally, if you are planning something like a plant near to the sea, then desalination plant would be a solution which is on a long-term basis, and that will solve your water problem for the time of the whole project period, right? So that is one important part. Another part is the storage of hydrogen. Obviously, this is dependent upon the size of the renewable energy, because as the size, if you don't have the banking, then definitely the storage of hydrogen increases to get more CUF for the hydrogen plant. And finally, the transportation. If you are talking about, it depends upon that. If you are planning for a distributed type of hydrogen project, or if you're talking about a project which is a central one, and then you plan to give the hydrogen, then everything will depend upon that, and based on that, transportation is one of the factors that affects this. Then we will talk about green ammonia. Now, in the green ammonia, around 1 ton of ammonia requires around 185 kg of hydrogen and 860 kg of nitrogen. This is just a conversion factor, which I'm just mentioning to you, that how much of ammonia is required. So as you see that land in this, in the ammonia, usually when you talk about ammonia, you're talking about export, because in India, it would be more like export terminals in different states and different ports, where you will set up a much more bigger sizes plants of approximately more than a gigawatt of capacity in terms of hydrogen or ammonia. And for that, obviously, you need land near the port, because that helps you in reduction in the cost of transportation, and obviously you need the jetty space, the ship, the vessel space at the port itself. Okay, so again, we also have to understand that to be competitive, see, as of now in today's scenario, the green ammonia is not viable. I mean, if you're talking about current size of the project, the green ammonia is not viable. Obviously, you need a size, much more bigger size plants, as well as you need government support in terms of whether it is subsidy support, or whether it is support in terms of banking, power, right? So these things definitely matter, which will actually give you competitiveness against the long-term price of ammonia. As of now, the short-term price of ammonia in India has ranged from $665 to $800 per ton. Obviously, this is you can say this is viable. If you talk about green ammonia at this price, you can definitely generate green ammonia at $800 to $900. However, it needs to be seen that this is not a long-term price, and this price may go down as I think the Russian war if the Ukrainian war is not there. I mean, that is what I think. But if someone can give more information on that, so if that is not there, then the price of ammonia will reduce drastically. It will definitely reduce below $400 to $500, and that is the price of ammonia one should target. Finally, when you're talking about export market, the European Union has come out with a delegation act for green hydrogen import, and that has to be discussed in a very in a long-term basis, right? Okay. Yeah. So let us talk about market opportunities. Now, in the terms of market opportunities, when we're talking about one, I will talk about green hydrogen, other is I will talk about green ammonia. In terms of green hydrogen projects, this particular size of the projects I'm talking about is more on the distributed sizes. For different sizes, I have mentioned these industries. For example, if you are planning to set up a 100 nm cube plant per hour to 1000 nm cube plant, which is about 1 to 5 megawatt, you should target steel industry, which actually uses annealing process in their hydrogen. Then the glass industry is there. They actually use hydrogen to avoid unwanted oxidation. So that also increases the efficiency. Then in the chemical, pharma, food industry, the hydrogen is being used in the hydrogenation process. And finally, the thermal power plants, they have hydrogen has a very high specific heat, so it can be used as a coolant. So these are the industries which actually look for capacities of these plants. These are very smaller plants, I would say. These are the plants which actually, this is more of a distributed one. When I say distributed one, I mean that these plants has to be set up at the company's premises itself. However, you can set up the renewable energy part outside the company premises, right? So this is one. These are the industries which look like. Then capacities of 2000 nm cube, more than 2000 nm cube, which is about 10 megawatt to let's say up to 300 megawatt. This I have generalized in a very you can say big way. But when you talk about like for example, when you talk about steel industry, in the steel industry there is a process called DRI, direct reduction of iron, and then there is a blast furnace they use. So here currently they are using coal for their power requirement. If we are able to use, if we are able to replace this coal or the fossil fuel, I would say with green hydrogen, definitely the capacity increases multifold. They have a requirements of upwards of 300 to 400 megawatt of electrolyzer. So that's a pretty big industry if you ask me. As of now, the steel industry is going towards there. They are talking about green steel. So what they have done is that they have actually changed the DRI process itself. They have and the blast furnace. So they have modified their blast furnace and the DRI process in such a way that they can use hydrogen gas as the fuel for their power requirement, for their heat requirement, right? So this is the one process. Similarly, glass and cement industry, they again, if someone is replacing the fossil fuel with hydrogen, then definitely these are the industry. Finally, when we talk about two major industries, which is a fertilizer and refinery, these are the industry which definitely are if you can say that they regularly use ammonia as their for making fertilizers, and for which hydrogen is required. As of now, they are importing a huge amount of ammonia from outside India, as well as they themselves generate ammonia by using they themselves generate hydrogen by using natural gas. So obviously the government is planning to actually put some kind of cap for using green hydrogen in these industries. Similar to refinery use hydrogen in desulfurization process, and definitely again the government is planning for such kind of cap for this industry as well. So these are the two major, if you can say, combination of central and distributed plants for green hydrogen. When you talk about green ammonia, this I will be talking majorly about export in terms of green ammonia. So if you talk about capacity of ammonia, we are talking about of 0.175 million tons to 0.87 million tons of ammonia. This is basically the why ammonia is simply because it is very easy to transport. Hydrogen is a very difficult gas to store and transport. You can just, because of the huge amount of volume it needs, it is not feasible to store it for longer hours, right? So the quantity, I'm talking about the size of the vessels and all these things, compared to ammonia, which is easy to convert into liquid form and then can be stored. So these things can be done easily, so that it is easy to transport ammonia on a longer distance, and therefore it is easy for export as well in the outside markets. Now, if you see the major markets in the world for ammonia, other than India, leave India part, but other than India, there is EU, which is planning for a 10 million tons of hydrogen, which will be equivalent to 50 million tons of ammonia. Okay. Similarly, Japan is planning for a 3 million tons of hydrogen, and South Korea is only 3.9. So this is a requirement of these countries by 2030. And if you ask me when these projects of these sizes will come up, I believe that it will come in 2027, 28. This will be the years in which major ammonia plants and green and hydrogen and ammonia plants will be working and start exporting these things to these countries. Again, primarily used in these are very similar to what India will be using. But they use ammonia directly. Sometimes ammonia is being directly used by power plants, fertilizer companies, chemical, shipping industries. However, we need to understand that there is a very important part of certification. Now, certification for green hydrogen and green ammonia for these projects is necessary before they actually certify these projects giving green hydrogen. So EU has their own understanding, own requirement of certification. So once it is certified, only then it will be called green ammonia, or green hydrogen or green ammonia, and they will buy that at that particular price. Right. One of the very simple regulation is that for the EU is that you cannot use old renewable energy plant for running this ammonia and green hydrogen plant. You have to set up completely a new greenfield project in terms of renewable project, and then probably they will start working on that. Other than this, there is oxygen is also a byproduct in this process. It is almost 8 times of hydrogen in terms of weight, and usually that can be sold in the market at rupees 15 to 20 rupees per meter cube. But this is a general retail price. However, on a long-term basis, at a mass scale, it will depend upon that time, and this is the case, right? So, yeah, that's it.
Okay.
Yeah, before ending, I just wanted to thank Santosh and Smart Energy Utilities for providing this opportunity for me to talk. And please go ahead and let me know if you have any questions.
Yeah. So I guess thanks a lot for this wonderful presentation and coming on this webinar despite your busy schedule. So the forum is open now for a question and answer. So if there is any questions that you want to ask to Mr. Vivek, then the participants can go ahead, unmute themselves and ask the questions before we proceed to the other presentation that we did.
Sure.
Good afternoon.
Hello.
Yeah, go ahead. Just give us your name also, and then ask your question. Yeah, go ahead.
Yeah, I am BP Balda. Just
Yes.
I want to know, is there any basic software where we applicant can apply it, and what is the approval procedure? What I want to say, software is in such a manner that within a specified time, approval procedure must be completed.
Are you talking about the approval process for setting up the ammonia and hydrogen plant? Is that what you're looking for?
Yeah, I am talking about the green hydrogen procedures.
No, so there is no specific software or which actually provides these details. You have to work it out that what exactly is the capacity and what exactly is the requirement by what is the capacity of the plant you're looking for, and based on that you can decide on the renewable energy capacity as well as the hydrogen capacity.
No, just what I give input, we have to give this input to central government. If you
Okay.
have to develop such type of software, so parallel approval procedure will reduce our approval.
Right. So, sir, see, I will tell you frankly. So there are 3-4. So government has not, even though government has said that they will make a single window clearance for all these projects, but they have not yet come out with a single window clearance. They have mentioned it in their policy, but they have not come out with yet. And in that, as you said correctly, there are multiple permission clearances for each and every projects, whether it is ammonia, whether it is hydrogen. You have to take a government MOEF clearances for these projects and the EC clearance for this project. So ultimately, once you have decided that you want to go ahead, then you can apply for this clearances with the central government.
Yeah. So next, hello again, BP Balda speaking.
Yes.
Yeah. Hydrogen is an explosive gas. Everybody know very well.
Hydrogen, yeah, it is.
In the gas group too. So, what is the safety precaution? Because it is a highly explosive, so safety is a very, very important. What about our view for the safety of hydrogen?
So see, first of all, even though hydrogen is flammable, it is very similar to natural gas. As of now, we are using natural gas in an abundant way, even at our home, to any places in industrial places, we are using natural gas. I agree that there is more inflammability in hydrogen. Obviously, you have to take the permission from the explosive petroleum and explosive departments, which is called PESO, and you have to take care about all the safety parameters for this.
Okay, thank you.
Good afternoon. My name is Abhijit Rajguru. Thank you so much for this presentation. I have 2 questions from my end. One is in relation to the type of electrolyzer that you would suggest, taking into consideration the intermittent sort of an operation that you have when you're talking of the renewable energy sources, both the solar PV and the wind energy. And my second question is in sync with what was asked earlier. When it comes to green hydrogen generation projects, what is the area classification that one should be taking into consideration while designing the entire plant? Thank you so much.
Okay. So answering the first question is basically why a particular technology is better, or why and how do you choose that? So as of now, if you ask me in today's scenario, based on all the risk parameters, I will talk about risk. Risk means how much a technology is being tested, how much it is proven, how much it is commercially available in the market. That has to be considered. Obviously, other factors like efficiency and all those things is definitely is very important. But the risk factors is also important for a long-term investors in these projects. So as of now, we see that alkaline-based technology is the cheapest one as of now, and it has a very similar efficiency what the PEM electrolyzer is providing. I will not talk about SOEC and AEM because they are yet to come at a level we can say it's highly commercial. But in terms of pricing, the PEM has a higher cost. Obviously, it definitely has its advantage in terms of, as you said, intermittency of power. But that can be solved if we are putting, if you have a banking facility available, or if you have a higher storage available, right? And if you can set up a bit of higher amount of renewable energy, and if you can set up a PSP, let's say, right, pump storage plants, then all these things factor can solve the problem which alkaline has it in terms of intermittency. So as of now, in today's scenario, yes, alkaline is better, but I definitely think that PEM will be viable in next 3 to 4 years, and it will be very similar to the pricing and probably better than alkaline. Who knows? So that's the answer for the first one. In the second question, you were trying to understand the area classification. See, if you're talking about distributed, as I said, distributed hydrogen plants. When you say distributed hydrogen plants, I mean that you have to set up the plant in the premises of the client itself. So you don't have to worry about the distance, the transportation cost, right? The only thing you have to worry about is how you will put in the renewable energy from your plant, which is outside the premises, to the hydrogen plant. So that is for the distributed solar or distributed hydrogen. But when you talk about, let's say, centralized hydrogen plants, or even a plant which you are planning for export of hydrogen or ammonia, then you definitely have to see that like if you're talking about centralized, then you should try to put the hydrogen and the hydrogen plant co-located with the renewable energy plant. That's the ideal one. So you avoid this thing, but definitely you have to see that it should be near to the client to again avoid the transportation cost as much as possible, or reduce the transportation cost as much as possible. If you can set up a pipeline, it is a no-brainer. But again, pipeline has its problems with setting up. You have to get a ROW, and there might be a cost involved. Plus, you may have to put an underground pipeline. So again, there is a good amount of cost involved. But it gives a stability for a longer period without any worrying of a leakage or major leakage or anything like that. For the export part, you should see that what port has what facilities, and what is the available pricing near the port, and whether you can get you can say berth for your ships at the terminal, wherever is the export terminal you are planning for, right? So these are the things which has to be looked into area classification.
Let me come back to the second question. When we are talking of biomethane or renewable natural gas projects, we know that the entire plant has to be designed taking into consideration the area classification as zone 2 gas group 2A 2B,
Right,
temperature class T3 T4. Now my
right.
question is that when it comes to the green hydrogen production going through the electrolysis route,
Mhm.
what is it that the standard specifies in terms of the area classification to be implemented?
Okay, so see, for specifically for hydrogen, they have not defined the zone actually, if you ask me, but it will be very similar to what natural gas uh, plants would look like. So it will be that only. Uh, uh, so I mean that's a very clear understanding there, but they have not defined specifically for hydrogen separately, but that has to be discussed. So once you start going to for the clearances and for the project to set up the location and everything, you have to see that in which particular zone actually this lies, right? So yeah, you are right on that part, definitely.
Thank you so much, sir. Thank you.
Okay, fine. So I guess like we can understand that there are going to be more questions, but as more presentations are lined up, it's quite possible that you might get some of your answers in our next presentations that are there. So thanks, Vivek Prasad sir, for answering the questions, and thanks a lot for coming on this webinar.
Yeah, thank you, gentlemen.
So coming to the next speaker that is there and the presentation that is there. The next speaker is Mr. Kiran Kumarala. He's a senior director at Plug Power Industries, and he's going to speak on developing green hydrogen in India, technical and commercial perspectives for total cost of hydrogen. Before I hand over to him, a brief introduction about him. He's an energy sector professional with 27 plus years of diverse experience in various functional roles across diverse sectors. He started his career as a junior sales officer and has moved across industries, varied roles, growing throughout. Learned that success needs commitment, and with that, any role plays situation would unravel itself into a similar set of challenges, and a focused effort can see you through it all. He is a responsible, able, and willing and reliable employee, a happy mind, and an avid reader, and a constant learner with an open mind. I welcome Mr. Kiran Kumar to this webinar and request him to give his presentation. I will be sharing the screen. Just give me 1 minute.
Okay. Hi, good afternoon, everyone. Thanks to Smart Energy and Santosh for organizing this webinar and giving me an opportunity to speak here. Okay, so as soon as I can share my screen, I'll get started. Yeah, thanks also Vivek for the detailed presentation. Okay, so I think I can share my screen here. Okay, can you see my screen now?
Yes, sir. Yeah, you can go ahead.
Yeah, okay, great. So yeah, Vivek gave a kind of very market-oriented perspective on how can we kind of produce green hydrogen, green ammonia, and sell it in the market. And as you can see in his presentation, there are many uncertainties because green hydrogen is a very sunrise sector. So there are many things that need to be figured out. So however, Plug Power is a slightly different kind of company. So I'm not going to the full screen mode because it's kind of difficult to manage. I'll just show it like this. I hope it's fine. So Plug strongly believes that hydrogen is the molecule of a green revolution. So the most important emphasis is on the green energy revolution part. So as a company, we defend it, we advocate it, we engineer whatever it takes to deliver complete systems for this remarkable and sustainable energy source. The key, again, emphasis is on the sustainable energy source. So green energy and a sustainable energy source is what hydrogen is. So that's something very, very important we need to keep in mind. It's not just another opportunity, not just another business opportunity. It's very important that it's directly linked to our sustainable future. Now, about Plug quickly. So Plug is a 25-year-old company and has been doing hydrogen from 25 years. It has a ton of patents. And at Plug, we have more than 1 billion hours of hydrogen operational experience. So that's something very, very important. We now have more than 2,500 employees across the globe. Maybe it's touching 3,000 now. We have a large number of fuel cells operating using hydrogen currently in service. We consume about 40 tons of hydrogen on a daily basis. And as you can see on the screen, we are building a complete hydrogen ecosystem. So apart from the renewable energy sources, we have technologies to produce hydrogen, technologies to store hydrogen, liquefy, transport, and then again, bring it back to gaseous stage. We also have dispensing solutions, and finally, hydrogen consumption, both in terms of as an industry feedstock and also as mobility and also as stationary power kind of solution. So since we have presence in the complete end-to-end hydrogen production to hydrogen consumption, at least maybe I'll take some liberty in making certain statements based on our experience. So, okay, so Plug story started with a very, very simple application, but that is now commercially proven application. So that's a keyword. So commercially proven is the keyword here. So Plug has been in fuel cells, but then when it met customers for various applications, one application that stood out is replacing a battery in a fuel cell and replacing it with a battery with a fuel cell and using hydrogen to fuel it. So this application, we found major traction, and customer asked Plug to supply the hydrogen so that they can not be worried about where to get hydrogen, where to store hydrogen, how to dispense it and all. So, and Plug has been doing this for a long, long time now. And as I said, more than 60,000 fuel cells are in operation. All of them use hydrogen, and more than 50,000 refuelings happen every day. And these refuelings are done by the operators. So as you can see, if you follow the code, if you follow the standards, right, you can actually handle hydrogen fairly in a standard manner, just like Vivek mentioned, just like natural gas, and maybe a little bit more easier. So not very complicated there. So we bring this hydrogen utilization experience to the table, not just equipment manufacturer. So then comes on this screen, you can see the various products, ecosystem of products that we have. So as I said, we have electrolyzers and liquefaction. We are actually building a green hydrogen production network in the United States. So we have plans to reach a capacity of 500 tons per day of green hydrogen by 2025. We have solutions for green hydrogen delivery. You've seen the trailers, hydrogen trailers that can transport hydrogen from across the country or continent. We have hydrogen refueling stations. And as I mentioned in the previous slide, the starting application was the fuel cells in forklift trucks. Now that is getting extended to light commercial vehicles and many other different kinds of vehicles. I don't know if anyone of you have noticed that there was recently a flight which used hydrogen for flying. It was actually powered by Plug's fuel cell. Similarly, the last and most important application is stationary fuel cells. So we are now starting to deliver a megawatt scale fuel cell for electricity for backup applications, not on the grid exactly, but in areas where grid is not available or grid will take time to reach. So but power is required now, the clean energy is required now. So that is another application we are seeing a lot of traction. We also provide the service and maintenance, and we can help customers develop their own ecosystem so that they can actually adopt hydrogen today, not tomorrow, need not wait for tomorrow. So that's what Plug does. Coming to hydrogen production, Plug invested in the PEM electrolyzer technology. Our fuel cells are also PEM fuel cells, but the electrolyzer selection has been done based on the key merits of the technology. As the previous speaker mentioned, there is a general misconception in the market that alkaline is currently cheaper. And if you talk about future, a lot of people say, yeah, PEM is promising, but AEM is coming, so that will be cheaper in the future. But let me tell you, PEM is currently the competitive technology and mature technology, and PEM will remain a competitive and mature technology in future. So if you see how the direction in which all electrolyzers are moving, so alkaline is moving towards how PEM is designed, how PEM is modular, right? How PEM kind of works. Similarly, anion exchange is a combination of alkaline technology and the operating principle of PEM. On the other hand, PEM is continuously improving. PEM has in operation for last 40 years, right? This particular electrolyzer technology was being supplied to NASA and even space station and other places. But now the key idea is it's not lab scale, but it is megawatt and gigawatt scale. So what you see on the screen on the left side is a megawatt, 1 megawatt stack. So that is a building block for our electrolyzer solutions. So we have set up a gigafactory, and now we have a capacity to produce about 100 megawatt per month. And as you can see, there is a clear roadmap to reduce the precious metal usage significantly, and the energy density will increase, stack size will increase. So there are multiple threads by which the technological development is happening. So I would like to say that PEM is competitive now, not 3-4 years. I would say 3-4 months rather. And we definitely know it. It's not a question of who knows this, but we actually know it. That is the reason we are invested in PEM technology. And in terms of maturity, we can talk about the maturity because we are using the same stacks, same electrolyzers for producing hydrogen in the United States right now. I think we have a 10 tons per day capacity already in place, and we'll be installing another 150 tons per day by end of this year. Okay, so what you see on the screen is a containerized 5 megawatt system. So this is a container opened on one side. You can see the stacks here. So there are about 5 stacks. So this is therefore a 5 megawatt stack. So there will be other containers for the other utilities, and we will be delivering one such system to India in a month or two, and you will definitely notice in the market. So Plug has been working with industry leaders on providing them hydrogen solution. You can see right from market leaders like Amazon or Walmart or IKEA, and you also see the automotive players like even BMW, General Motors, and many other companies using our solutions. I can tell you one very interesting application. In Germany, in an electric car manufacturing company, they use hydrogen fuel cells for their forklift trucks. So it's very important to understand that hydrogen has a specific advantage, and in certain use cases, it is currently, even at the current prices, is competitive to other solutions. And as our webinar organizer kind of mentioned earlier, India, interestingly, has taken a very direct stand that we will not let this opportunity pass. We will do what is necessary to be in the game, be a major country in the hydrogen ecosystem. We don't want to simply take technology, but we want to manufacture, we want to develop, we want to be a critical country in this hydrogen ecosystem. Plug, through one of its acquisitions, now has 150 engineers in India, and they're all working on electrolyzer systems and fuel cell systems. So I think we have the largest team working focusedly on hydrogen in India at this given point. Okay, I will diverge a little bit here. Let me talk a little bit about why hydrogen. Why are we talking about hydrogen? So there is always a question, the argument that, oh, we need to shift to green energy and clean energy, right? And we should use as much renewable power in the grid first, rather than using it for green hydrogen. Actually, so it's not a competition between clean energy for electricity grid versus clean energy or renewable energy for hydrogen. If you think about it, the real challenge in front of all of us is decarbonization. And if you see from a decarbonization perspective, after the top 1, 2, 3, 4, 5 countries, global hydrogen consumption produces the highest amount of carbon dioxide emissions. So it's close to 1 billion tons of CO2 emissions per year right now. So this is a slightly dated information, but it is close to 1 billion tons of CO2 per year now. Now, that means this hydrogen is already being produced from other methods. There is carbon emissions. There is a lot of experience in using this hydrogen. There is a commercial value of using this hydrogen. So there is nothing to be cracked here except the production part of it. And by displacing or replacing this gray hydrogen, the advantage is the scale up required for clean and green hydrogen will be provided by decarbonizing global hydrogen. And that will provide the cost reduction and scaling that is required in order to bring hydrogen to other sectors and other solutions. It is not just for 1 or 2 applications. Actually, green hydrogen and clean electricity will go hand in hand in a complementary manner. If you see this graphic on my screen, you can clearly see the electric grid infrastructure and the hydrogen infrastructure, they feed into one another. So this is a illustration by Department of Energy in terms of how hydrogen and electricity can support each other. So initially they might look like competing for the same resources, but actually they are highly complementary and they will definitely support each other, both in terms of reducing the cost, improving the reliability, and reducing the greenhouse gas emissions, which is the ultimate goal why we are actually looking at hydrogen as a solution. Because we all know that hydrogen is nothing new. We all know about hydrogen. It has been there for a long time. But it's the carbon emissions that are driving us to consider cleaner options. And in order to adopt it widely, we need to reduce the cost. So that's the key motivation. This is something we should not lose focus. The competitiveness, one, yes, we should look at from a rupee per kg or rupee per calorie kind of perspective. But we should also look at carbon intensity for energy use perspective as well. If we lose sight of the carbon, we are losing sight of the future. By focusing only on the dollar or rupee value, we are only focusing on the present, but we are losing focus on the future if you don't consider the carbon intensity. So that's something we need to be very cautious about, not lose that focus, not say this is not competitive, because we are building the future on this foundation of clean energy. Solar, when it started, it was like 17 rupees per kWh, but today it is 2 rupees 50 paisa. Even if you add storage, it will be competitive for other technologies. So it has reached where it has reached because we supported it in the beginning. Same thing with green hydrogen and green ammonia. It's very important to consider what we are doing right now. The first 5 years is like the foundation. So the focus should be on carbon intensity. The focus should be on adopting to as many applications as possible and see how we can reduce the cost in the coming years. So just in line with this, if you think about it, I mean, one of the thinking that Plug is trying to do everything in the value chain is that integrated technology creates a flywheel effect. So each of these applications will help each other. So industrial decarbonization will reduce the cost of hydrogen and it increases experience of handling hydrogen. That will automatically, we already know that material handling, I showed you, we already have a lot of experience. This will be helpful in on-road applications. This will help in stationary and data center decarbonization. Similarly, finally, we can go towards aviation and many other applications that can come. So it's very important that hydrogen should not be seen as a limited one area application, but it will start in one area and then expand into other areas, and it will go along with clean electricity. So both will go hand in hand. So that's, I think, the key thing we need to keep in mind. So if you, at a high level, I know Vivek went into a little bit more nitty-gritties, but I'll show a slightly high-level motivation. So in India, we all know that we are we import a lot of energy. We spend at least 100 plus billions of dollars every year to import energy. So, and second, we don't have domestic gas, so we import a lot of gas. So this is a key motivator, because ultimately, as we have seen, both in times of COVID and also because of the war, the disruption in supply chains and also energy supply chains. So there is a need to create energy security, and clean energy is energy security, right? No country in a war can go and block your sun. No country can block the wind that is coming to you. And if your hydrogen production is inside and you can store for a long duration, you have that energy security dimension taken care of. The other dimension of clean energy is you invest in the technology now, and for a certain period of time, you don't face inflationary pressures. So the inflation elements in clean energy are much significantly lower compared to other energy sources. We want to be a hydrogen export hub. We have a large domestic market. We have definitely a lower cost of labor and abundant availability of technical resources. And also the solar and wind potential we have significant. I think all this makes it India an ideal location for green hydrogen. And we are seeing the interest both from the government and also from other players in the market. Now, yeah, these are the key sectors where we'll find applications. I think Vivek kind of went into it, so I will not go into it in detail. But the industry feedstock is where the maximum focus is on. That means the left side. Then comes to the natural gas blending. Then the applications of transport and electricity will happen. So transport and electricity will be more of pilots. Natural gas blend is more of a demonstration. Industry is where the real major takeoff will happen in the initial phase. Okay, so this is one slide I can spend a little bit more time, because this is the key topic that I thought I'll talk. The total cost of hydrogen is not a simple thing to do. we all know, we all want to put numbers, right? We all just want to give some inputs and then want to get an answer. Unfortunately, it is not that simple. And in the last 10 years or so, we have done a lot of clean energy development. So therefore, it gives us a sense that, oh, all you have to do is provide certain inputs, we'll get the output. It is not so. Hydrogen is a little bit more complicated than other clean energy kind of projects. So therefore, it's important to take the multiple dimensions and also understand the trade-offs that are there between each of these parameters. I'll quickly go over this, and maybe if you have questions, we can discuss. So the cost of electricity occupies a lion's share, right? If you take a really 25-year perspective, people typically talk about 70%, but I would say it will even cross close to 80% of the cost, because this is one cost that will not reduce. So it will stay as it is, and it is directly proportional to the kgs of hydrogen you produce. So therefore, this cost will remain as is. So it's important, therefore, to figure out the right kind of electricity input. So whether would you want to co-locate, whether you want to do decentralized production. So that's an important thing. So also the T&D losses and charges are critical because they are not visible, but they impact the whole cost. Lastly, the important thing is availability and reliability of electricity. So here comes the dimension of variable renewable energy resources. So it's important to understand, if you are using variable resource directly, the technology should be suitable. But let us say someone says, no, I will use storage, I'll use banking and many other opportunities. So in such case, what happens is the reliability of grid will come into picture. So you might have a storage somewhere on the grid, a pump storage, but if the grid fails, your system will have to stop, right? So when you stop and restart, so every start and restart, for example, I mentioned it here, there is an output lost in start-stop cycles. So it's very important to understand the grid reliability dimension as well while selecting the electricity input. So not only cost, but also qualitative aspects of electricity are important. So then comes the real critical part, which is the operational parameters. Before we go to CapEx, we should look at what kind of plant are we trying to set up. So what is the total annual output required? How many hours we want to run? So there are some processes which are okay to switch off, which are okay, which are flexible. They actually shut down every year, a month or so for maintenance. So they are different. There are certain processes like, for example, steel, where they don't want to shut down. Any stoppage will lead to huge material waste. They want to run 365 hours, 365 days, 8,760 hours if possible, right? So depending on that, that's also a very, very critical parameter, because certain technologies require more maintenance, certain technologies will require no maintenance. So that's another important thing. The third one is the hourly output. So this decides the actual sizing of the system. So the hourly output is the one which decides the sizing of megawatt sizing of the electrolyzer, not the other two parameters. And the last and most important thing is, what is the operating input range? I mean, we rate the electrolyzers in megawatt, not in hydrogen output. Unfortunately, that's the industry convention. So therefore, we have to think about what is the input range I want to operate it. So because that decides what is the current density of the electrolyzer. So a lot of people don't understand that alkaline operates at like 5 times lower current density compared to PEM electrolyzer. PEM electrolyzer operates at like 3 amperes per centimeter square. So various alkaline is always definitely less than 1 ampere per centimeter square. The highest I heard is half ampere per centimeter square. So that automatically has a bearing on certain other parameters. So now I'll come to the CapEx. CapEx, a lot of people simply look at total, they think that, the stack of PEM is very expensive because it uses precious materials and all. But the reality is the system cost comprises of 3 important components: the stack, balance of stack, and balance of plant. Yes, I would definitely agree that PEM stack is expensive compared to alkaline. But when it comes to balance of stack, PEM has an advantage because the footprint is small. You have to lay smaller cables. The stack is stackable, so you actually save a lot of material and efforts in balance of stack. And same thing also goes to balance of plant, because there are other parameters like pressure and purity where PEM scores, and therefore the cost of balance of plant will be lower. So overall, on a system cost level, if you think about it, alkaline and PEM are today competitive, because as Plug Power, we have been winning projects across the globe, including in Europe, where we have seen competition even from other alkaline players. All the major alkaline players we have been competing and we have been winning projects. So it clearly shows that we are competitive. So therefore, I would say PEM is competitive right now. The other important parameter for capital expenditure is the land availability. Depending on the land availability, you have to choose the technology, and sometimes the land cost could be something significant. And the most important thing is your land should be available not only for your initial demonstration or a pilot project, but it is required for the complete hydrogen capacity you want to set up on your location. So that's something you have to kind of plan. The EPC cost is important because this has a bearing on the footprint of the electrolyzer. The bigger the footprint, your civil cost will multiply. The rest of it may not change, but the civil costs are significant. That can change the balance. The supply assurance is very important aspect. Because unless you get the electrolyzer supply in time, you'll not be able to deliver in time and you'll not be able to start generating revenue. So this impacts the project development duration and the uncertainties related to it. Why I put project development duration is because this will impact the interest during construction. Now, the cost of capital, as the earlier speaker mentioned, the technology's maturity is very, very critical. Because if a bank sees a mature technology, there are already reference projects in place, then it becomes easy to finance and the risk assessment is lower. Similarly, the offtake agreements and the total plant life also impact the cost of capital. Now I'll come to the operational parameters. So when you're operating, obviously the efficiency is the most important thing because this has a direct bearing on electricity. So electricity input cost and efficiency, they both kind of plug into each other. But here you have to look at what is the efficiency at stack level, what is the efficiency at balance of system level, balance of stack level, and finally balance of plant level. So, right, that's a very important thing. And second, some of this is impacted by the pressure and purity that the customer is looking for, the application is requiring, right? So PEM technology actually produces output at a very high pressure. So you don't need external compressor. So external compressor not only means external additional capex, but also additional point of failure. So that impacts the reliability, that impacts the output lost in start-stop cycles. So that these are some operational parameters one need to model very, very carefully before arriving at total cost of hydrogen. The last and slightly simpler one, but actually a very impactful one is the operational expenditure. The manpower cost is generally very, very small. But we have to keep in mind that it doesn't increase as per inflation. Manpower cost can increase significantly if you don't get experience and expertise manpower that is required to maintain the system. So the electrolyzer, PEM electrolyzers they don't have any electrolyte. They simply use water and electricity. You will get hydrogen. So it's very simple to maintain and it is actually remotely monitored. Similarly, the larger the system space the system occupies, you would need more people to handle it because one cannot run 100 meters from one end to another end in few minutes. So you definitely need more manpower, and the complexity of the system actually means you need more people and more expert people required. So this is something that needs to be really carefully modeled. Otherwise, this number can hit during operations. Consumables is one part of the story, but disposal of material, any waste material is an important cost that we ignore right now, but that can increase significantly going forward. The stack reliability, not the life, stack life is there, but stack reliability is also important because there is a cost of lost production. So you are not looking at the project cost, but you are looking at the opportunity cost. So that is another important thing. So if you are sourcing from a place where you cannot get spares easily, where you cannot get support easily, then you are increasing your cost of lost production significantly. And lastly, the stack life, which is a replacement cost. A lot of people think that, oh, this is very, very important. But I would say that any stack life, imagine it is more than 80,000 hours. So you are looking at least 10 years. And in 10 years, the cost of stack will go down significantly. So it will not be very, very high. But if you are looking at a 40,000 hours or 20,000 hours, you have to model this, and that could be significantly high because the cost of stack would not reduce in so many, 2 years or 4 years. It will take at least 5 years for the stack cost to come down significantly. So so this, I'm sure all of you know this. One advantage the government has shown their commitment is by providing waiver of interstate transmission charges for 25 years. That means if you set up a plant now, you can actually have free transmission charges free transmission, interstate transmission for 25 years. So this kind of benefits developers in a significant manner. So this is something we need to take advantage in India. Another dimension I wanted to show was that a lot of people think that, oh, electrolyzer cost is very, very significantly impacting. Actually, if you see this graph, this is from IRENA, it is not. So if you see the cost of electrolyzers being 1/3, right? Even then the reduction is only less than $1, right? So, but the electricity price being $65 per megawatt hour versus say $20 per megawatt hour is where maximum cost reduction is happening. So this is something we need to keep in mind, that electricity cost is something that needs to come down. And as more and more electrolyzers are established, the cost of electrolyzer actually can reduce faster than the cost of renewable energy. So what the reduction that we have seen in solar can happen in hydrogen. But the important thing is it needs that scale right now. So the current installations are the foundation on which future cheaper electrolyzers will be built. So today's installations are as important as tomorrow's installation. And yeah, lastly, see, transitioning into a decarbonized energy era is neither a sprint nor a marathon, right? It's not a race. There is no finish line. So it is a daily routine. It's a fundamental habit that needs to build on small changes leading to a transformational change. And we need collaboration at every level. So we need all the ideas, all the players available, and all kinds of solutions. It's not only ammonia, it's not only hydrogen, it could be methanol, it could be any other solution that can decarbonize. So it's not this or that, but it must be this and that. So with that kind of, I'll take a break, and if you have any questions, feel free to shoot. Yeah, what you see on screen is a 120 megawatt site that we are developing. I'll leave you with that. Any questions? I hope I finished quickly.
Thanks a lot, sir. Thank you very much. So, if there are any questions that are there, participants can simply ask.
Santosh, your voice is low, yeah. But
Yeah, I said if there are any questions, the participant can ask the questions.
sure.
Mr. Ala, this is Abhijit Rajguru from Clark Energy India.
Sure.
Thank you so much for such a wonderful presentation. I have a couple of questions in relation to Plug Power. My first question is the 5 megawatt installation that you intend to have within the next couple of months, is that where the stacks are being built within India, or is it something which is the entire module is going to be imported from US?
Oh yeah, yeah. So currently, let me answer that quickly. So the whole 5 megawatt is being shipped from internationally. So the stacks currently are being manufactured at our gigafactory in Rochester, where the capacity, as I said, is 100 megawatt per month. So it's not in India at this point.
Okay, my second question is when it comes to the PEM electrolyzers in specific, and when you're talking of the blending projects, what is the pressure at which hydrogen gets generated from the PEM electrolyzer?
Yeah, so this slightly varies from OEM to OEM. Our electrolyzer produces 40 bar output.
Okay, and my third question is in relation to system integration.
Right.
When you're talking of solar PV, renewable energy coupled with wind, or maybe just standalone solar PV, renewable energy feeding the hydrogen electrolyzers, any installation that you have globally where it's a straight DC to DC connection, taking into consideration the Joule effect and making sure that, yes, the plant does perform satisfactorily?
See, DC to DC is something I have explored even with fuel cells. Okay. But there are practical challenges. So there is always some kind of isolation required between one system to another system. But that's a area in which the development is going. So that's something we might be able to see in maybe 3 to 5 years, not immediately. But there are systems that are directly coupled to renewable energy. which will directly produce power to X kind of fuels.
Right. Thank you so much, sir.
Welcome. Okay, I think I'll hand it back to Santosh for the next speaker.
Yeah.
And if there are
Thanks a
any
lot,
questions, we can look at the end.
Yeah. Thanks a lot, sir. Thank you very much for this wonderful presentation and for your time to coming for this webinar. So we move on to our next speaker that is there and the next presentation that is there. So we have Mr. Samrat Sengupta. He's the VP Business Development at EKI Energy Services Limited. And he's going to speak today on carbon footprint reduction opportunities of green hydrogen in hard to abate sectors in India. Before I hand over to him, a brief introduction about Mr. Samrat. Mr. Samrat Sengupta is the climate and renewable energy professional and policy campaigner with 2.5 decades of experience with proficiency in the carbon market and renewable power business strategy and development. At EKI Energy Services, he is responsible for new business line development in the climate change vertical. I welcome Mr. Sengupta for this webinar and request him to take it forward from here.
Thank you, Santosh, for the nice introduction. And thank you, Smart Energy and Santosh, to give me this opportunity. Hope I can share my screen now.
Yes, sir, you can share the screen now. Yeah.
Okay. Yes. Hope it is visible.
Yes, sir, it's visible. You can go ahead.
Yeah, thank you. And thank you, Vivek and Kiran, to nicely lay down the micro-technical and technical aspects of project development on green hydrogen. And this makes, I will be talking, being not from the sector technical specialist, I am coming from the climate angle, the carbon market angle. I will be talking on that perspective. So I represent Enkin International or EKI Energy Services Limited. That's Enkin International, our brand. This is a 1.5 decade old carbon market player which has been originated from a small city of Indore in Madhya Pradesh and become a multinational global unicorn and probably the largest in terms of volume of carbon credit being traded into the voluntary carbon market. We have offices in 16 countries and client base from 40 countries, mostly from the southern hemisphere. But yes, as the trading happens in the northern hemisphere, few important countries in the northern hemisphere too. So we started our journey in 2008 and yeah, in 2021 we became the first publicly listed entity in particularly carbon market domain in the world. And yes, we are growing at this moment. All the other and we are providing services to sustainability, net zero, climate investment, offset management. That includes carbon and other environmental derivatives, as well as capacity building among the industries to attract this very important form of environmental derivative based revenue system, which may in long run going to support commercially justifiable investment in novel technologies, which has a impact on the carbon footprint of that particular business operation. So Kiran has highlighted why it is green hydrogen is so much in the perspective. I will thanks for that. That makes my speech much more shorter and easy. I like to just highlight another perspective that in the overall energy transition, which has been instigated by the existential problem of greenhouse gas emission or anthropogenic greenhouse gas emission and related global warming we are experiencing now. In the with the beginning of industrial revolution, which happens in the 1850s or time, uh, what what has been done, everything is right, but there was one particular thing which we have not done right at that time. We haven't able to internalize the cost of ecosystem, the cost of natural resources in our overall financial balance sheet, in overall product and service costing. And that creates a unnecessarily exorbitant and not efficient consumption, which has led to all sorts of environmental problems, including climate. Now we are trying to do an energy transition. We are trying to do a retrofit on a technology which we are hostage for 150 years. We are not doing any transformational here. What we are trying to do, that end use electrification. And almost all decarbonization activities, except few nature-based solutions or blue carbon activities or CCS, which is not related to CCS. I am hearing it for last 25 years. Nothing has come out from the laboratory. I am not very hopeful personally. So if we can check out the 10% of it, everything is related to electrical energy. And the part, the thermal, where the electrical energy direct end use is not possible, hydrogen become a success story in bridging that gap of end use electrification, because we are shifting for a very concentrated source of energy that is fossil to a very dilute form of a source of energy that is renewable, and only bridging gap in the retrofit efforts of our technological retrofit is the electricity. And hydrogen playing an important role where direct end use electrification is not possible. And here hydrogen is not the energy source, it is the energy carrier. And we have also to see on the carbon footprint aspects, what is the life cycle impact on any technologies. Hydrogen definitely is very low compared to that. That's always acceptable, but there are few technologies being propagated in the present market as a kind of a measure on going green. In a life cycle assessment, that has serious question. And I'm not personally a technical expert on the green hydrogen and its various kinds of electrolyzer and its modes, but I will also like to hear from speakers who will be talking about various technological options in terms of electrolyzer, both on the national perspective, because the webinar agenda is national. What is the sustainability and security aspects on the material balance of those kind of technology which we are trying to promote at this moment in India. Obviously, we cannot develop our indigenous manufacturing on a single day. It requires a sustenance effort. But on the technology, on the material, both upstream supply of the material aspects, how secured on a geographical boundary position of India we are going to address by promoting hydrogen. Now, as I have already talked about and shown that almost 10% of the total decarbonization story up to 2050, it is taken from IRENA study, is depend on hydrogen and hydrogen to hard to abate sectors. Green hydrogen needs from this has already been sufficiently deliberated by Kiran and Vivek. I don't want to spend too much of energy because on that, but it's mainly the present hydrogen utilization, not the green hydrogen, the hydrogen present gray hydrogen utilization. There are substantial gray hydrogen utilization which Kiran has shows around, and the fifth or sixth position is the total global carbon emission footprint is considered from hydrogen utilization. That's the possibly the first state area where there is the consumption, as well as in the um, efforts of hard to abate sector, including metallurgy, including fertilizer, including oil and gas, particular segment of the oil and gas downstream segment of it, and also in heavy transportation, long haul cross country transportation. That's possibly the first area. And on the costing perspective, if we since this is talking about same thing, 28% of the industry carbon footprint is on coming from this hard to abate sector. So 28 plus few percentage, almost 30% of hard to abate sector. This is the data of I think IRENA also. Now, on the green hydrogen production costs, break-even construction, there is lot of micro discussion has happened. I just want to highlight the two various industrial player, including Kiran, Vivek, and everything, that on the carbon market perspective, this green hydrogen is getting lot of attention because it is ultimately going to reduce a substantial carbon emission or avoid substantial carbon emission from various hard to abate sectors. And in carbon registry system, already methodology been developed. It is under approval where project developer can register their projects as a green hydrogen uh, carbon emission reduction projects, and the credit will be going to be sold at a premium, and that may create a substantial revenue flow to support the initial cost parity or cost differences it has, and create some kind of enabling environment for the industry to go for it. One way to avail the market revenue benefit by sale of these environmental derivatives in the form of carbon credit. The other way, the major export oriented project developer or export oriented business entities who generally supply product or services to countries in the northern hemisphere, CBAM going to make a huge problem for them, and reduction of their per capita product or services footprint will help them to overcome that barrier and make them more competitive in the international market. In both way, this carbon accounting either to avail a direct revenue flow or an indirect competitive advantage in the form of footprint can be availed, and we are one of the largest in the world who provides all those services. Now, competitiveness of green hydrogen, yes, it has been studied by McKinsey, and they have with few, definitely there are few assumption parameters has been taken on, and it has been shown that by 2030, more or less the green hydrogen will be competitive in the present refining methanol, ammonia, which already has been told, and maybe in closer to 2040 or beyond, the competitiveness on a aggressive scenario will happen on the long haul transportation as well as a power storage or the because we have to add on so much renewable or variable power to our systems, so storage is definitely going to play. It is not battery or farm storage, it is not hydrogen or farm storage, that kind of debate. Every technology should be used based on its pros and cons. So storage will be viable through green hydrogen process. So but when we decide for green hydrogen adoption, material sustainability and security on the particular technology we choose within this country should be taken on. Yeah, like lithium-ion battery case, I can say that is getting into another oil kind of a situation. So we should not take that or we should learn from that aspects. Even in the renewable energy, like Kiran has said in beginning, it was in 16, 17, 15 rupees per kWh, and now it has come down to 2.5 rupees. But we have to also see the amount of investment to do in the renewable energy projects development. It definitely generates clean power to us, but the co-benefit aspects the country is losing beyond our boundary. So we are not able to get 100% of the co-benefit associated of that intervention within our country. We should not create such situation, and green hydrogen is too novel sunrise sector. We can play an important role. Indian policymakers and industrial sector can play an important role on that. Business competitiveness, CBAM, I have already indicated to. Also, for the industry, it will help them to be attract a better ESG score. And with the financial institution getting more and more active on ESG being a main part of their risk assessment for investment analysis, and TCFD guideline, and even SEBI is taking some for a step. RBI has already declared something. So more and more this environmental, social governance issues is making a mainstream agenda, and getting a higher score will definitely help industry or project developer to attract more green money. And at the end, obviously, in this so-called environmentally uh, aware or aware stakeholders level, brand equity on working on something which is green will definitely help. So just like to conclude, and thank you, Kiran. Thank you, everyone. It just like to highlight in the beginning, I means just like to highlight that one shots of support this green hydrogen initiative can get from the carbon market is the revenue stream. The other short of supports is the lowering of carbon footprint and related sub benefit in the ESG and brand equity aspects. Thank you.
Yeah, thank you, Mr. Sengupta, for this wonderful presentation. So if there are any questions to Mr. Sengupta, participant can ask, or else we move to the next speaker that is there.
Sure. I would like to just make a brief comment.
Yeah.
See, the carbon offsets, we all know that the carbon trading platform draft has been released, and we expect that government will come up with that shortly, which will improve possibility to reduce decarbonization, right, through many other solutions where you cannot do it directly. So I mean, I feel green hydrogen and carbon offsets have a hand-in-hand role, because where the customer uses the green hydrogen to reduce his emissions, he can generate carbon offset and generate more revenue. And in other case where someone wants to produce hydrogen but offset some of the carbon emissions if he uses grid power using offsets, that is another possibility. So you can use offsets for green hydrogen production and also use green hydrogen production to generate offsets. So I think there is a nice complementarity that can be developed between those two sectors. Thanks.
Yeah, thank you, Kiran, for the comment. Yes, that is the national ETS, which is Government of India is planning, but the international market is already active. If you are at this moment generating green hydrogen, you can take the benefit from the international market. And that's there is no red tapeism, nothing is there. We are trading almost last year we have not from green hydrogen per se. The overall trading happens in the range of 90, 98 million tons of carbon, and that's substantial. And India is almost covering 30% of the total supply in international market.
So thank you, Mr. Sengupta, for this presentation and being part of this webinar.
Thank you, Shantosh. Thank you for giving me this opportunity.
So moving on to our next speaker, he is Mr. Charit Konda, financial analyst at Institute for Energy Economics and Financial Analysis. He is going to speak on potential ways to make green hydrogen economically viable in India. Before I hand over to him, a brief introduction of Mr. Charit. Charit is engaged in research and policy advisory for more than a decade and a half in energy and related sector, including oil and gas, power, largely renewable energy, climate finance, and sustainable growth. His interest lies at the intersection of government and private enterprise in the sector of infrastructure, energy and environment, mobility and technology. Charit holds a master's degree in finance from the Institute of Chartered Financial Analyst, India, and a bachelor's degree in commerce from Acharya Nagarjuna University. Welcome, Mr. Charit, and I request you to take it over from here.
Thank you, Mr. Santosh. I hope you can hear me. And thank you for the audience for being here and all the speakers. So today I'm going to speak on the topic of potential ways of reducing the cost of production. So I guess the speakers who spoke before me have touched cost in various angles and have spoken about it. So I'm glad that they have made my job easier. But I just gonna reinforce some of the insights and thoughts that the previous speakers have spoken about cost. Mr. Santosh, I hope I can share my screen.
Yeah, you can share your screen. Yeah.
I still get host has disabled my
No.
screen sharing. Can you make the host?
Yeah, I have already made you the host actually. You are actually you have to share your screen, I guess.
Yeah, I'm trying to click on the share screen.
Santosh, you have made Mr. Bharat Bhai as the host, not Charit. You have to just redo it once.
Okay, just give me 1 minute.
Yeah.
Yeah.
Now it's possible? Just check it.
Yeah. Yeah, I hope you can see my screen.
Apart from speaker, can I request everyone to go on mute?
I guess Charit, you have to mute Mr. Bharat Bhai. He's outside actually. So and then you can
Okay.
Yeah.
Okay.
Yeah, fine.
Okay.
Yeah. You can go ahead.
Go ahead.
Yeah. Sorry for that. So yeah, my name is Charit. I work as an energy analyst for the Institute for Energy Economics and Financial Analysis. Today, I'm going to speak about potential ways to reduce cost of green hydrogen production. A brief snapshot of our institute, otherwise known as AIFA. We are a think tank that examines issues related to energy markets, trends, and policies across the world. And our mission is to accelerate the transition to a diverse, sustainable, and a profitable energy economy. And we have analysts working across continents of Asia, Australia, Europe, and America. And we work with a wide variety of stakeholders, including industry, government, policymakers, and academia as well. So that's a brief background of AIFA. So just to set a context, I'll very quickly go. So don't feel that I'm repeating things, but these are important things just to drill down on some of the points that the previous speakers have spoken about also. So what is driving green hydrogen or hydrogen made through renewable energy is a versatility of its applications, which makes it a very important part of the net zero ambition. So it's going to play a critical role in terms of achieving net zero ambition. So the versatility is it is in industrial and agriculture, as well in energy form, and for electricity sector and transportation as well in the long run. So this versatility makes it an ideal source. Secondly, again, it could help hard to abate sectors such as steel production and heavy duty transportation in the medium to longer run when it comes to shipping and heavy commercial trucks in terms of transportation. And again, as some other speakers spoke, it improves energy security because it reduces dependence on fossil fuels as we talk about green hydrogen replacing the conventional hydrogen, because it can be produced locally with domestically available renewable energy resources. So these are the primary drivers. There could be other drivers coming in the future with cost competitiveness coming forward, and a carbon market coming into play. But these are the current drivers. So applications again, what are the near term? If you can divide it into near term and medium and longer term. So it is in the near term, I think the low hanging fruit is opportunity to replace the majority portion of the around 6 million metric tons per annum of conventional hydrogen. That is what we call a gray hydrogen, which is made out of natural gas, which is being used in oil refining and fertilizer or ammonia production. So in the near term, if you can cash on to that opportunity, that would be the basis for further growth of green hydrogen sector. In the medium and longer term, steel production and heavy duty transportation, including shipping and heavy commercial vehicles come into play. And also hydrogen as an energy storage could also play a role in the medium to longer term. Steel production, as you all might know, it requires change in the production process, and additional capex is required. So it might take some time and for a green hydrogen to pick up on competitiveness among the fuels. Yes, it's just not all a story of ups and so there are certain challenges as well. So there are downsides, or there are challenges in terms of tapping into the opportunities that green hydrogen could give. One is, as you all know, the cost of green hydrogen compared to the conventional or the gray hydrogen is twice as much as the one that is gray hydrogen is used. Is produced through which is produced through steam methane reformation. That's another process, as green hydrogen is produced through electrolysis of water. So so cost is a major challenge as of now. And second thing is another discussion is whether we use existing RE generation capacity, or do we need to deploy additional renewable energy generation capacity. The way the world is going forward, or at least the advanced markets such as Europe is going forward, is to set up additional generation capacity, renewable energy generation capacity to produce green hydrogen, because the existing renewable energy already has competitive uses in the market. So hydrogen should be an additional to the existing green initiatives. So according to Government of India estimates, only India needs 125 gigawatt of additional renewable energy capacity to produce its target of 5 million metric tons per annum of green hydrogen by 2030. And of course, again, one more cost component is the electrolyzers that we talked about. So these we need to build capacity, domestic electrolyzer manufacturing capacity. Currently, 80% of the world's electrolyzer manufacturing capacity is held in China and Europe. So again, the same exercise of what we are doing in solar PV modules, we should be replicate that for the electrolyzers as well. And all combined, again, who would finance this green hydrogen transition? So according to government estimates, again, we need $8 trillion of investment to achieve our 2030 target of 5 MMTPA of green hydrogen. So these are the main challenges that the industry has to counter. Now, right. As my topic is, we are talking about costs. I'm not going to talk about the remaining aspects much in detail, but I'm going to focus on the costs. So at a high level, if you look at, so how do we analyze the costs? As one of the speakers said, it's very difficult to look at the costs in give them numbers. We all like this comparison to do, but for the sake of this discussion, I thought of putting it in numbers. Take it as an estimated number. Take it as an intelligent guess. So, but what we need is some kind of comparison. So again, the world is debating whether we should call it green hydrogen, blue hydrogen, gray hydrogen, and assign various colors, or we just go with the percentage of carbon emissions per kg of hydrogen. So this is currently, this discussion is happening in international forums, but for the sake of this discussion, let's go with the existing definition. So as you can see, green hydrogen is anywhere globally costing $3 to $6 a kg, depending upon where the plant is and what kind of energy costs it's incurring, compared to the conventional gray hydrogen, which is $2 to $2.5 per kg. And blue hydrogen is nothing but conventional hydrogen, which is gray hydrogen, equipped with carbon capture and utilization and storage. Now, again, this is a very highly estimated cost because we don't have such projects neither in India or globally. So, again, so these costs could be further drilled down as I go forward, but roughly the capex and opex costs again depend on variety of factors, including the type of technology that you use for electrolyzers, their efficiencies and throughput or utilization, construction cost, construction period, and financing cost as well. So yeah, if you dig deeper and see what are the cost components that primarily, there could be multiple cost components, but at a high level, if you divide these into certain buckets that we could compare, there is a capex and opex cost, right, across the colors of technology of green hydrogen production. And then there is an energy cost, and then add to that transmission and distribution for green hydrogen and carbon capture and utilization costs for blue hydrogen. So if you see the major component for green hydrogen, which makes it twice the cost of gray hydrogen, is the energy cost and the cost of supply of that energy to the green hydrogen plant, which is nearly up to 70% of the total cost of green hydrogen at this estimated cost at this point of time, and which might go further high as electrolyzer costs comes down. So roughly, if you take renewable energy generation cost of rupees 3 per unit right now, it translates to 2 per kg of in US dollars of the cost of green hydrogen. And again, transmission and distribution charges are a major cost component, which again adds to 2 to 3 rupees per unit of electricity produced, depending on where you are positioned in India. So again, this will translates to 1 to 2 kgs per of green hydrogen, which in turn coming to 6 kg per green hydrogen. So in a way, government has recognized this cost, I would say. So they have recently waived of the ISTS charge, which is the interstate transmission at the on the CTU, the central transmission unit. So this will have a material impact because you're looking at 70% of the green hydrogen costs. So again, as I said, for blue hydrogen, CCUS charges are estimated charges. We are not very confident on those, but for the sake of this demonstration, it might account for 30 to 35% of the blue hydrogen costs. Moving forward, so what needs to be done? So what are the cost reduction levers? If you see, as we spoke about reducing the renewable energy generation costs as well as the transmission and distribution costs is critical to lower the cost of green hydrogen to somewhere around $2 to $2.5 per kg if you are looking to replace gray hydrogen competitively. So roughly, if you take a thumb rule or a kind of a benchmark, is if the per unit cost of rupees 1 of kilowatt hour of green electricity will translate to somewhere around 75 cents to 1 kg US dollars per kg for green hydrogen. So this is something that policymakers and all of the industry holders can stakeholders can keep in mind in terms of how low we should be aiming for this energy costs and the supply costs should come down to achieve competitiveness in green hydrogen. Again, interstate transmission, as you know, realizing this importance, ISTS charges are waived off earlier till 2025, now very recently extended till 2030. So any plant even set up in 2030 for the next 25 years need not pay for ISTS, but the plant should be able to directly connect to the CTU, as you know. Using state transmission lines again incurs additional charges. Also, government has subsidized or specified that cross subsidy and additional surcharges would not apply for RE. Now for renewable energy for green hydrogen, which is also important. But I cannot stress the importance of this further. So further reduction in transmission and distribution charges would improve the viability of green hydrogen plants, especially if you are not close to CTU and you are using state transmission lines. This is something that state governments also should look into. STUs should look into of lowering these costs. And again, sometime earlier I said about installing domestic manufacturing, deploying this capacity for electrolyzers. This is also important in reducing capex requirements. So as we talk, very recently, government is also drafting an incentive package of around $2 billion, which will be worth rupees 30 or 37 cents per kg for green hydrogen production. So this can come in terms of production linked incentives or tax credits or VGF. In terms of again, it's not for electrolyzers alone. So what initial reports indicate that this $2 billion of incentives, almost 70% would go for the RE renewable energy generation and supply cost, these incentives, and the remaining 26% to 30% would go for electrolyzers. So largely, I think when the market develops, it's a mix of incentives and as well as economies of scale would make a lot of difference for bringing down the cost of electrolyzers. And some other cost reduction levers, another important metric or lever is the partnerships are required. So this is cannot be taken in silos. This is a capital intensive industry, whether we like it or not. So we need learnings in the market from other sectors, and we need partnerships among capital providers, technology holders, EPC companies, logistics providers, and end users themselves to develop a robust supply chain that could drive down costs. Now, Europe is somewhat attempting that in developing hydrogen hubs. So this is something that brings all of these players, other than the capital providers, at one place to drive economies of scale and reduce the costs in the supply chain. Again, you can see the market moving that way. Some recent collaboration agreements were signed between the Indian Oil Corporation with IISc Institute of Science, Greenstat of Norway for electrolyzer technologies, and L&T and Renew Power to bring other expertise, power generation and engineering expertise to IOC. And ONGC likewise has tied up with Greenco Zero C private limited company, and Adani with Ballard Power Systems, Greenco with John Cockerill of Belgium. So these are, I think this is a way to go forward in terms of reducing costs. Partnerships will go a long way. Again, we think as an institute, there should be some kind of mandates for use of green hydrogen, especially the ones in the industries that are currently using gray hydrogen, which are the oil refineries and ammonia production. So this will create is create initial demand that is required. So there'll be first adopters, and it will help build the industry. So I'd certainly believe we as an institute believe there should be some kind of similar to renewable purchase obligation in RE industry, renewable energy industry, is a kind of mandate should be there, which could be gradually increased, not immediate implementation of a high target, but gradually increased target. And what this does is also creates demand certainty, and it makes easier for the projects to come online by reducing the cost of financing for green hydrogen plants. And another missing piece, also touched by another speaker earlier, was the certification of green hydrogen, which is missing. So again, huge debate in internationally what can be constituted as green hydrogen. Is 90% or 80% of power used should be renewables? Would you call it green hydrogen? Or should it be 100% or some other percentage, right? So this is very important. There should be some kind of a government body, interdepartmental coordination should be happening, and then they should be tracking the origin and the quality of green hydrogen. This would help establish the market, help introduce standardization standards in the market at an early stage, and it will help exports and trading in international markets also. And this also, again, as I said, it's a capital intensive industry. So what constitutes as green hydrogen, if we could define and certify it, it will boost international investor confidence and attract investments into the green hydrogen projects. So with this, I'd like to end my presentation and hand over to Mr. Santosh.
Yeah, thank you, Charit, for this wonderful presentation. So before we move ahead, if there are any questions from the participants to Mr. Charit, you can have it actually before we move on to the next speaker.
So looks like either I made a very good presentation or I haven't made any sense.
It was a very good presentation. So I guess the questions that were there, they are definitely going to be there, but we can move ahead and wait.
Yeah.
there might be some questions that will come up.
Sure, no problem.
Yeah, so thanks a lot, Charit, for coming on this webinar and giving time for this webinar.
My pleasure. Yeah.
So moving on, we have our next speaker, that is Mr. Nishant Balashanmugam, and he is India representative for the Green Hydrogen Organization. He is going to speak on the need for global standards in green hydrogen. Before I hand over to Mr. Nishant, a brief profile about him. Nishant is a highly accomplished professional with a diverse background spanning the automobile and renewable energy. He has been associated with leading companies like Honda and Ford. Currently, Nishant is focused on combating climate change through his role as India representative for the Green Hydrogen Organization in Geneva, Switzerland. Green Hydrogen Organization is a registered Swiss non-profit organization launched at the United Nations General Assembly in 2021 with a mission to accelerate the adoption of green hydrogen to reduce carbon emission from other energy sources and forms of hydrogen. Welcome, Mr. Nishant, to this webinar. And
Right, Santosh, I'm going to assume you gave this over to me. You could.
yes, I'm handing over to you.
I do have a presentation that I'd like to load up.
Yeah, now you're a host. Yeah.
All right, thank you very much. I'm just trying to figure out how do I, oh yeah, I see this. All right, is my screen visible?
Yeah, your screen is visible. You can go ahead. Yeah.
All right, fantastic. Thank you, Santosh, and everyone else. Greetings. My name is Nishant, and I'm the India representative for the Green Hydrogen Organization. So I think in my introduction, you mentioned a little bit about us. So our primary mission is to accelerate the adoption of green hydrogen globally. And we've been active for the past 2.5 years. We will launch the UN General Assembly in 2021. And we have a global footprint. We operate across 5 continents now. And our sister organizations are the Africa Green Hydrogen Alliance, which is primarily active in Africa. In India, we have the Green Hydrogen Organization India, and we have another sister organization in China. And we're also present in Australia and North America, and including South America as well. So I think everybody here spoke about why green hydrogen, and these are the reasons why we were formed as well. If the world could produce 100 million tons of green hydrogen by 2030, we could reduce a significant amount of carbon emissions in the world, and this will keep us on track to reducing temperature rise up to 1.5 degrees. So I will, I'll not go deep into this, but I'm sure we've all established that most of the initial green hydrogen adoption will have to come from all of these sectors you see here, right? From your refining to fertilizers, steel, shipping, and then your heavy trucks. Now, the Green Hydrogen Organization is also a multi-stakeholder group. We work with the UN bodies, we work with governments, we work with finance institutions and private companies, civil societies, and communities, including think tanks and knowledge hubs as well. So in India, we've been active over the last several months, and some of our hubs and international partnerships include our partnership with the Egyptian government for their Center of Excellence. And in India, we are partnering with the Uttar Pradesh government, and specifically UP NEDA, which is their renewable energy arm, to set up a Center of Excellence here in Lucknow. We are in talks with an Indo-Danish partnership to set up another Center of Excellence, possibly in Chennai. And we are also partners with the Center of Excellence for Hydrogen in IIT New Delhi, which was instituted by Gexcon and Greenstat through an Indo-Norwegian partnership. So we also liaise with all the several embassies here in India through various bilateral initiatives they may have, examples being GIZ, Business Sweden, the Indo-German Energy Forum, and several of them. Another big partnership for us is our partnership with the International Solar Alliance, something which was just signed less than 30 days ago. So the International Solar Alliance is a government-to-government organization that helps promote solar and adoption of solar across the world. And they have about 120 member countries. So the ISA has a green hydrogen mandate, and the Green Hydrogen Organization will be their partner in implementing these mandates across all their member countries. As part of its G20 efforts, we've partnered to build a center of excellence with ISA, which will focus on policy, skills, safety, and standards as well. India's green hydrogen landscape, we all know the government is very active here. And like I think Kiran mentioned, or it was Vivek, India's import of fossil fuels is tremendous. It's close to about $160 billion a year, I believe. And these also contribute to a lot of carbon emissions. So India has very good reasons to move away from this and adopt something like green hydrogen. And added to that, we have one of the cheapest renewable energy costs across the world. And in line with all of this, we are seeing record amounts of investments for renewables here. And I think the government is looking at about 10 million tons of green hydrogen production by 2030. So today I'm going to focus on the Green Hydrogen Standard, which was developed by our organization beginning COP26 in 2021. So as our previous speaker mentioned, the previous speakers mentioned about the need for standards in this evolving industry, we recognize this need in 2021. And at this point, there was no organization that was looking at setting standards for green hydrogen and certifying green hydrogen production. So we've developed a standard. We are running pilots across the world right now. And in India, we have two of the major companies in India partnered with us and running the pilot right now. And we have several other companies in Australia, Chile, Africa, and Europe. So why do you need a green hydrogen standard? Only when you have a certificate can you know this was green hydrogen, because you could take any form of hydrogen and claim this to be green hydrogen. So there has to be this transparency and clarity. Now how does having a standard help? It will help secure getting government approvals and support. It will help you sign offtake agreements. It will also help you with financing, because right now we've had several of our partners who are financial institutions come to us and ensure that most of their projects they're financing runs our standard or runs our pilot, just to ensure that whatever they're doing is in line with ESG requirements, SDG goals of the United Nations, and ultimately producing green hydrogen of the best quality. So our green hydrogen standard also adheres to sustainability standards, and this will strongly influence pricing and export opportunities for anybody implementing this. Now, customers and consumers want hydrogen that is produced with close to zero emissions. And therefore, something like the Green Hydrogen Standard will help you meet this need. So I'm going to skip this slide. All of this maybe this is something important. I will go through this one. So why do you need a green hydrogen standard? When you start early, it helps you mitigate a lot of risks. It helps you identify risks, and it helps align your project with global best practices. Now, the green hydrogen standard is not just a certificate mechanism where we give you a certificate of origin. It's not only that. We also ensure that you are engaging with the communities, you are using right water resources, there's health and safety, and there's accountability for your projects. So as you can see, we are very concerned with the impact of this industry on communities, on land, because in our past, we've made these mistakes and then we've realized them and we look to correct. So through the green hydrogen standard, we want to ensure that any green hydrogen that is produced sustainably. So one of the key features of the green hydrogen standard is a definition for the green hydrogen standard, which you see here. For every 1 kg of green hydrogen, there has to be less than 1 kg of carbon emissions. And this is mostly scope 1 and scope 2 emissions. And this is only until production. Now, I'm sure I don't have to define green hydrogen for this audience. Most of you all are well aware of this. So like I mentioned earlier, our standard requires that environmental, social governance consequences of green hydrogen production are addressed. Our standard requires that development opportunities and impacts of green hydrogen production are fully considered. Now, going into our certification and accreditation process. So when we support early stage projects, we provide support for scoping pre-feasibility studies, and we ensure that you have access to best practices and guidance. Now, best practices and guidance in green hydrogen contracting and legislation is another initiative from our organization. We've partnered with 12 global law firms to build this guidance for how you get your land agreements sorted, how you get your offtake agreements, dispute resolution, and all of this. So in addition to that, we will support with engagement with governments, with host communities, investors, lenders, and customers. And on the second stage, the accreditation of project that will meet the green hydrogen standard, we will engage an independent assurance provider. Like for now, our pilots are being done by DNV. We will have stakeholder engagement and public comment, and then this project will be reviewed by GH2's accreditation body. And once this is done, the projects will be licensed to use the label GH2 Green Hydrogen. Finally, what our certification does, it gives you global recognition, and it'll give you a certificate of origin. And we have a standard not only for green hydrogen, but also for green ammonia. Now, since that is a very extensive process, we've developed something else called the rapid assessment tool. And this is in so many ways a smaller version. And no, we will just go through all of these frameworks we've developed and ensure that your project is in line with all of the requirements. So ultimately, these standards are being set across the world right now. Australia has their own standard. The EU is coming up with their own standard. The Indian government has had a stakeholder group through which they've consulted, and they've just submitted their proposal. Now, how are we different is we will align ourselves with national practices, with whatever requirements are here nationally. We will ensure whatever production is here done in India. We will give you a compliance certificate letting you know that you having used these subsidies and this kind of renewable energy is permitted for exports to the EU, or it's not permitted to export to Japan. It is only permitted to Africa, etc., etc. So this is what we are aiming to do through the green hydrogen standard and our certification mechanism. We want to align with national standards that exist, but we want to harmonize global standards as well. So through this, we will facilitate global trade of hydrogen, and we will ensure there's sustainable development of green hydrogen. So that'll be the end of my presentation. Open to questions.
Thank you, Nishant, actually, for this short but very important presentation, touching upon the global standards. And I guess as India hopes to become an global hub for green hydrogen, these standards are going to play an important role. So if there are any questions to Mr. Nishant, participants can kindly post their questions to him.
All right, if there's any further questions later on, I'm available on LinkedIn, and the Green Hydrogen Standard is available on our dedicated website. I will share the website into the chat box shortly. And our organization, we are open to working with other companies, other institutes. So, if you want to collaborate, please let us know and feel free to reach out. Thank you.
Thank you, Nishant, for coming on this webinar and adding value to this webinar. Thanks a lot. It was a nice presentation.
You're welcome, Santosh. Thank you for having me.
As we come close to the ending of this webinar, one of the main questions that or the aim of the National Green Hydrogen Mission is to make India an hub for production and export of green hydrogen. So very quickly, actually, I would like to know from all the speakers, those they are present right now, what is their take on this particular question of making India a hub for the production and export of green hydrogen. So if all the speakers can quickly add their views on this, it would be a nice point to close this webinar. So Nishant, you are already there. So could you add something on this particular question that is there? So the aim of making India a hub for the production and export of green hydrogen.
Well, I think the central government and the MNRE, they've set a clear ambition and goal that we would like to export most of the green hydrogen here. And globally, India is one of the few countries that are placed favorably for production of green hydrogen. And I think only the few other countries are Chile and some countries in North Africa. But nobody has the ecosystem that India has. We have great availability of manpower, technical knowledge, and we are an economy that's growing rapidly. So India has everything that it needs to become, an export market for green hydrogen.
Yeah, thanks a lot for sharing this.
Santosh, if I may add, I think I second Nishant on this. India is appropriately or greatly positioned in terms of becoming the hub for production and export of green hydrogen. One, because of the large-scale availability of renewable power, both solar and wind, as well as a large coastline. So we could actually produce it and large manpower. So definitely drive down the costs of this green hydrogen and then position it as a global product which could be traded. Again, some of these matters of logistics, developing certifications, internationally aligned. There should be international standards, internationally aligned policies, so that we could be a hub for exports. Thank you.
Thanks a lot, Charit, for adding your views on this. Mr. Kiran Kumar, if you are there, you can please kindly add your views on this particular question or particular aim that the government is there of making India a hub for the production and export of green hydrogen. Yeah, okay, I guess Mr. Kiran is not there. Actually, he had some prior commitments and he had put a message also. But still,
sorry, I was on mute. Can you repeat the question, please?
Yeah, I said this is the final question that the aim of the National Green Hydrogen Mission is to make India a hub for the production and export of green hydrogen. So we would like to know your take on this. What are your views on making India a hub for this green hydrogen?
Yeah, I think, see, export largely depends on the macro environment, right? So there will be multiple forces that will fight for that market. But I think we have a robust domestic market with some support. We can get started. I think getting started is important. That will give us experience and opportunity to be able to kind of present a energy source for those countries which want to import. So we have to use the domestic market in order to be able to export. Both will go hand in hand. I think that's my view.
Yeah, thanks a lot, sir. Thank you very much. So with this, we come to the end of this wonderful session that we had with all the speakers participating and giving deep insights on the latest things or the
Santosh, I think we are not able to hear you.
Yeah, now you are able to hear me. Hello.
Yeah,
Yeah.
we can hear you.
Yeah, I said this is the end. This is the end of this wonderful session that we had with different speakers, giving deep insights into the opportunities that are coming up in this sector, the policy, the technology, the cost factor, the certification things that are there. So definitely, we look forward to having such more webinars in the future and more of the participants. I guess today's webinar has also added value to the participants in gaining knowledge about green hydrogen, the upcoming opportunities that are there, what are the things that they have to look and how the market is going to pan in the coming years that are there. So with this, I thank all the speakers and all the participants for joining on this webinar. And we look forward to having such more wonderful sessions in the future. Thanks a lot. Thank you very much.
Thank you, Mr. Santosh. Thanks, everyone.
Thanks a lot. Thank you very much.
Thank you.
Hey, thanks all. Thank you. Bye.